Hello students, in this video we will see the NCERT solutions of chapter 5, which is understanding elementary shapes. So starting with the exercise 5.1, what is the disadvantage in comparing line segments by mere observation? So by mere observation we cannot compare line segments with very minute difference, like if I say 5.1 and 5 centimeter. So this is the first disadvantage of comparing line segments with observation. So we cannot say which one is bigger with this minute differences. Second is, why is it better to use a divider than a ruler while measuring the length of a line segment? While using ruler, the chances of error are more because the thickness. Divider, at the divider end we have a tip which gives us the slight difference in the centimeters, minute difference. Divider can give us easily instead of the ruler because of the thickness of the pencil that you have. Third is, question is, you have to draw any line segment AB. Take any point C lying in between A and B. This is the practical question that you have to do. You have to draw the line segments AB like this. Then take any point C lying on it. Measure the length of AB को measure करो. This is what you will do with the ruler. Then measure BC and AC. So yes, it will come out to be that AB will be equals to AC plus C. This is the solution. This you can do it with the scale on your own. Fourth point is, if ABC are 3 points on a line such that AB is 5, BC is 3 and AC is 8, which one of them lies between the other two? We know because we have seen it from the another question. Given is that AB is, let me just, okay. AB is 5 centimeter, BC is 3 centimeter, AC is 8 centimeter. We know that AC plus, if we do AC will be equals to BC plus AB, right? Because 8 will be equals to 3 plus 5. That means B will lie in between A and C. Okay. Verify whether D is the midpoint of AG. You have to verify whether D is the midpoint of AG or not. So in this, what we will do, D is here, A is here, and G is here. So we will write that AG is how many centimeters? 1, 2, 3, 4, 5, 6 centimeter. AD is 3 centimeter and DG is 3 centimeter. That means D is the point lying in between these, because at the left of D also and at the left of D and the right of D we have 3 and 3 centimeter of difference. Okay. Or we can just see that half of AG is the half of 6, which is 3. So yes, D is the midpoint. If B is the midpoint of AC and C is the midpoint of BD, where ABCD lie in a straight line, say YAB is equals to CD. Now let's say this question, take it like that. We have a line let's do it here. Answer number 6. B is the midpoint of AC. AC is the line. AC is the line. B is the midpoint of AC. And C is the midpoint of BD, where ABCD lie on a straight line. Say YAB is equals to, now we know that B is midpoint, which means implies that AB is equals to BC. And C is midpoint of BD, That means BC is equals to CT. Now from 1 and 2, from 1 and 2, we can write AB is equals to BC is equals to CT. So it is being proved that AB is equals to CT. Okay. Now, seventh is you have to draw 5 triangles, measure their sides, check in each case if sum of the length of any two side is always less than the third side. Sum of any two length. You can draw any of the triangles, bache, with your measurement. But the case will be that the sum of any two sides will always be greater than the third side. This is the theorem as well. So you will consider this and you will get this. Okay. Coming to the exercise 2. What fraction of a clockwise revolution? You have to tell now in the clockwise revolution, does the R end of a clock turn through when it goes from 3 to 9? How these questions will be done? When we are going from 3 to 9, let's take answer 1, A part. I'm just doing the A part here. R's covered from 3 to 9 will be 9 minus 3 is equals to 6, right? So 6 hours are covered. In 1 hour, how many degree of angle is covered? 30 degree. So in 6 hours, it will be 30 into 6, which is 180 degree, right? So the fraction is part is 180 by total is 360, which is 1 by 2. Okay. You have to do all it like this. In 4 to 7, we cover 3 hours. So it will be 3 into 30, which is 90 by 360, which will be 1 by 4, like that. Now, second question is, where will the hand of a clock stop if it starts at 12 and makes half of a revolution? In half revolution, angle covered is equals to 180 degree. Okay. So if it is starting at 12 in 180 degree, hours covered will be 6 hours. Okay. So if it starts at 12, it will stop at 6. Okay. If you want to do it by the clock, you will make a clock starts at 2. Now this is 12, this is 6, this is 3, 9, 1, 2, 4, 5, 7, 8, 10, 11. So it starts at 2, it is starting at 2 and makes half of a revolution. Means 180 degree. So in 180 degree, it will be straight angle. So it will stop at 8. Okay, like this. If it is 1/4, that means it is covering 90 degree. That means 3 hours. So it will stop at 8. If it is 3/4, so 3/4 of 360, you will find it, which will be 270 degrees. And 270 degrees means 9 hours. So if it starts at 5, 5 plus 9 you will do, it will be 2. Which direction will you face if you start facing east? Now it is the direction question. It is north, south, east, west. If you are facing east, make half of a revolution clockwise. That means you are going here. Now you are facing west. You start facing east and make 1.5 revolution clockwise. Now 1.5 means 1 full revolution like this and then half revolution like this. So it is also west. You are facing west. Now you are facing west. and make 3/4 of a revolution anti-clockwise. Now you are making it anti-clockwise 3/4. This is 1/4, 2/4, 3/4. Okay. So it will be north. You are facing south and make one full revolution. So it will be south only, because after moving you will come to south only. It is not necessary to mention clockwise or anti-clockwise, because when we are making one full revolution clockwise or anti-clockwise, we will come to the same position only. What part of a revolution have you turned through? If you stand facing east, you are facing east and turn clockwise, you are turning clockwise to north. So it is 3/4 revolution. You are facing south, south, north, east, west. You are facing south and turn clockwise to face east. Again 3/4. You are facing west. You are facing west and turn clockwise to face east. 1/2. Find the number of right angles turned through by our hand of a clock when it goes from. For one right angle, in one right angle, 3 hours are covered. Okay. Multiples of 3. So 3 to 6, we are covering 3 hours. So that means one right angle. 2 to 8, we are covering 5 hours. So one right angle. 5 to 11, we are covering 6 hours. So 2 right angles. 10 to 1, we are covering 3 hours. So one right angle. 12 to 9, we are covering 9 hours. So that means 3 right angles. 12 to 6, 2 right angles. Okay. Coming to the 6th, how many right angles do we make? If you start facing south, you are facing south, this is east, this is west, and turn clockwise to west. How many right angle? 1. North and turn, you are facing north and turn anti-clockwise to east. So 3 right angles. You are facing west and turn to west, any of the directions, so 4 right angles, like this. Now 4th is you are facing south and turn to north. अब आप चाहे आप एंटी क्लॉकवाइज जाओ, चाहे आप क्लॉकवाइज जाओ, you will face 2. Where will the R end of a clock stop? If it starts from 6, it is starting from 6 and turns 1 right angle, so 9. From 8, if it is starting from 8, this is 8 and turns 2 right angles, means 8 plus 6. 2 right angles means 6 hours. So 8 plus 6, 2. From 10 and turns 3 right angles means 9 hours. So 10 plus 9 is 19. But in the 12-hour format, 19 means 7. From 7 and through 2 straight angles means full revolution, 360 degrees, so 7. Okay. Coming to the next exercise. Match the following. Straight angle, half of a revolution. Right angle, 1/4 of a revolution. Acute angle, less than 1/4. Obtuse angle, more than half. Reflex angle, between 1/4. 1/4 means 90 and half means 80. So no, one complete revolution you can say reflex. Wait. More than half a revolution will be this. And obtuse angle will be between 1/4 and half. This is complete. So this is not reflex. Okay. This is the answer. Coming to next, classify each one of the following as right, straight, acute, obtuse. A is acute, B is obtuse, C is right, D is reflex, E is straight, and it is acute, both. Coming to the next, this is all about what is the measure of a right angle? 90 degree. A straight angle? 180 degree. True or false? The measure of an acute angle is less than 90. True. Measure of obtuse is between 90 and it is smaller than 90. So false. Measure of reflex angle always greater than 180. Measure of one complete revolution? True. If M angle A is 53, B is 35, then 53 will be greater than 35. True. Write down the measure of some acute angles. You can write any 60, 45, 30 degrees. Some obtuse angles 92 degree, 110 degree, 172 degrees, like this. Measure the angles given below. Now you have to measure it with the protector and write down the measure in this. That you can do with the protectors. Which angle has a large measure? First estimate and then measure. We know that angle B is greater, this is greater, but you can measure it and then write. From these two angles, which has larger measure? I think this is the larger, you can measure. Fill in the blanks with acute, obtuse, right or straight. An angle whose measure is less than that of a right angle is acute. An angle whose measure is greater than that of a right angle is obtuse. Sum of the measure of two right angles is straight. When sum of two measures of two angles is that of a right angle, then each of them is acute. The sum of the measure of two angles is that of a straight angle, and if one of them is acute, then the other should be obtuse. Find the measure. You have to find the measure and then calculate. Find the angle measure between the hands of a clock in each figure. This is 90. This is 1 and 12. Whole is 360. So what will be this? 30 degree. This will be 180 degree. You have to investigate. Now measure and classify each angle. You have to measure first and then classify. This is acute. Like this, you will measure and then classify. Coming to the exercise 5.5, which of the following models are perpendicular line? The adjacent edges of a tabletop. Yes, these are perpendicular. The lines of a railway track. No, these are parallel. The line segment forming the letter L. Yes. The letter V. No, it is acute angle. Let PQ be the perpendicular to the line segment XY. PQ be the perpendicular to the line segment XY. Let PQ and XY intersect in the point A. Okay, this is going further down. It is intersecting at A. What is the measure of PAY? 90 degree only. Coming to the next question. There are two set squares in your boxes. What are the measure of the angles? One is 90 and one is acute. Study the diagram. The line L is perpendicular to the line M. Line L is perpendicular to the line M. Is CE is equals to EG? You have to just measure CE is equals to EG. Yes. Does PE bisect CG? Yes. Identify any two line segments for which PE is perpendicular bisector. Perpendicular bisector. So it is DF. It can be CG. It can be BH. AC is bigger than F. AC is bigger than FG. Yes. CD is equals to GH. Yes. BC is smaller than EH. Yes. Okay. Coming to the next exercise. 5.6. Name the type of triangles. Triangle with length 7, 8 and 9. Scalene. Triangle ABC with this, this and this. Also scalene. Triangle PQR such that PQ is equals to QR. Equilateral. DEF with MD 90. Right angled. It can be right angled isosceles because these are equal. LMN with 30, 70 and 80. Obtuse angled triangle. Because one of them is, oh no, sorry. This is acute angled. All are acute and scalene. Okay. Match the following. 3 sides of equal length. Equilateral triangle. 2 sides of equal length. Isosceles. All sides are of different length. Scalene. 3 acute angles. Acute angled. 1 right angle. Right angle. 1 obtuse angle. Obtuse angle. 1 right angle with 2 equal length. Isosceles right angle. Name each of the following triangle in 2 different ways. So this is the isosceles, and also coming to the triangles is acute angle. Then this is the scalene right angle. Then this is isosceles obtuse angled. Right angled isosceles. Equilateral and equilateral, you can say acute. Then this is scalene obtuse. Okay. Now you have to construct all these triangles. This is the practical question. Next exercise. State true or false. Each angle of a rectangle is right angle. Yes. The opposite side of a rectangle are equal in length. Yes. The diagonals of a square are perpendicular to one another. All the sides of a rhombus are of equal length. All the sides of parallelogram of equal length. The opposite side of a trapezium are parallel. Give reasons. A square can be thought of a spatial rectangle because in square we have all sides equal. When in rectangle we have all sides equal, then it can be. A rectangle is a spatial parallelogram because in rectangle we have opposite side equal and parallel. A square can be a spatial rhombus because it is all the sides equal and all the angles, opposite angles are equal. Okay, like this. Third question is, a figure is said to be regular if its sides are equal in length and angles are equal in measure. Can you identify regular, quadrilateral, square? Okay. Now coming to the next exercise related to all the polygons. Examine whether the following are polygons. It is not because it is an open curve. Polygons are always bounded. It is yes, it is a curve, not a polygon, and it is also not a polygon because polygons are only the line segments, not the curves. Name each polygon. This is 4 sides, so quadrilateral. This is triangle. This has 5 sides, so pentagon. This has 1, 2, 3, 4, 5, 6, 7, 8 sides, so octagon. Okay. Draw a rough sketch of regular hexagon connecting any of 3 of its vertices. Draw a triangle. Identify the type of triangle you have drawn. You have to draw a rough sketch of regular hexagon. 1, 2, 3, 4, 5, 6. This is a regular hexagon. Connecting any 3 of its vertices. Connect any 3 of its vertices. Draw a triangle. Identify the type of triangle you have drawn. Now, what type of triangle is this? You have to tell. This is exercise 5.8, right? This triangle is basically an isosceles triangle in which this, okay, if we draw any other type like this, one side like this, and then one point from this and this, we can see these are equal. So this is an isosceles triangle. Draw a rough sketch of regular octagon now. You have to draw a regular octagon. And then draw a rectangle by joining exactly 4 of the vertices like this. This is a rectangle. A diagonal is a line segment that join any 2 vertices of the polygon as not a side of the polygon. Okay, pentagon, you have to draw the pentagon. 1, 2, 3, 4, 5 and draw all its diagonals starting from this. 1, just a minute. Let me draw it again very clearly. 1, then 2, then from this 3, 4 and this. These are the diagonals. Okay. So this is all about the 5th chapter. I hope you have understood all the solutions. Thank you.